guys, welcome to my first educational tutorial. In this video, I'll be walking you through the step-by-step process of an important concept of chemistry called energy flow. I'll also be using the heat curve of water from left to right and right to left to demonstrate energy flow. But first, what is a heat curve? A heat curve is a graph that represents the different phases that a substance goes through as heat is added or removed over time. As you can see in this graph, or really any graph, there is an x-axis and a y-axis. The x-axis represents time, which is universal since time continues to move forward regardless of anything else. The y-axis represents temperature, since temperature changes as heat is added and time is passed. Moving on, there are 3 stages and 4 phases that this graph goes through. The stages are the period where the temperature is increasing over time, giving it a positive slope. In contrast, the phases are the period where the temperature remains constant, giving it a horizontal slope. First is the solid stage. Since this is the heat curve of water, the H2O takes the form of ice. This is when the compound H2O is below 0 degrees Celsius. This is also the stage that has the least amount of energy flowing through. On the microscopic scale, solids have tightly packed or arranged molecules that usually are in a regular pattern. Solid molecules vibrate, but generally do not move from place to place. On the macroscopic scale, think of this stage simply as an ice cube. Compared to ice's counterparts, water and water vapor, ice has the lowest amount of kinetic energy, heat, and temperature. Next is the freezing phase. In the freezing phase, the liquid reaches 0 degrees Celsius, which is water's freezing and melting point, and takes the form of a solid, in other words, from water to ice. Energy is being lost to the point where it can't maintain its liquid form and transitions into a solid. Think of this process as putting water in a freezer to lose its heat and freeze into ice. The next occurrence is the melting phase, which is the inverse of the freezing phase. In this phase, the solid is transitioning into a liquid, more specifically from ice to water. This is when H2O is at 0 degrees Celsius, as was stated earlier, the melting and freezing point for water. In this stage, the substance takes the form of both a solid and a liquid, since the melting is still in process. Think of this process as dropping ice cubes into lemonade. The energy from the lemonade goes into the ice cube, melting the ice cube, and reducing the lemonade's heat. After the melting phase is the liquid stage. This is the period where the H2O is above 0 degrees Celsius, but below 100 degrees Celsius. H2O is typically in liquid form at room temperature, which is around 23 degrees Celsius, because melting and condensation point is between 0 and 100 degrees Celsius. On the microscopic scale, liquid molecules are relatively close together with no regular arrangement. Liquid molecules also vibrate, move about, and slide past each other. On the microscopic scale, think of liquid water as a water in a bottle. At 100 degrees Celsius, water hits the boiling and condensing phase. During the boiling phase, the substance goes from a liquid to a gas as heat is added, particularly from water to steam. The first thing that people tend to think of when they're boiling is adding heat to a pot with water. The kinetic energy from the source, whether it's from the fire, electrical heating, or something else, transfers into the water through the pot that causes the water to eventually hit boiling point. After the boiling phase is finished, the liquid has fully shifted into a gas. The next phase is the condensing phase. This is the inverse of the boiling phase, since a substance goes from a gas to a liquid, or from water vapor to water. An example of this is water droplets forming on a cold window. The water droplets came from the moist air as the air was cooled down from the glass, causing the air to take liquid form. There are 2 more phases that I still haven't covered, deposition and sublimation.
But Outwit, didn't you say there were only 4 phases?
Well, yes, I did. That's why they're both honorable mentions. Deposition and sublimation aren't very common and are the 2 only phases that skip the liquid stage. The only difference is, deposition is a direct solidification of vapor by cooling, while sublimation is a direct vaporization of a solid by heating. If you were ever wondering why the phase changes are horizontal, constant, or is even increasing in temperature, the reason is that the heat added is used to provide energy to transition from one stage to another, for example from solid ice to liquid water. One more thing that I still have yet to mention is a different x-axis the heat curve can have. Instead of time for the x-axis, some graphs represent the amount of heat added. The heat added can be a constant, independent variable. Since I have to have a conclusion, teachers, I'll leave you off with this. Make sure you guys like and subscribe with notifications to the video. It takes 3 seconds only for slow and means a ton for me. Peace.